Hi, everyone. Bill Stanley here, and I'm happy to be together with James Hodgson. He's a research director at ABI, specializing in the automotive industry. At the recent MOVE event in London, there was some interesting conversation. And James, if I can ask you a few questions about the conversation that came up. We're seeing that connectivity has evolved from a nice to have in the automotive industry to being something that's fundamentally a requirement. Could you elaborate on the primary use case that you're currently observing in the market?
Yeah, sure, that's right. So obviously connected car is a well-established trend, but historically the way in which connectivity was adopted in the automotive market was in a very superficial way. You could have it or you could leave it. And the use cases tended to evolve around keeping the driver entertained, keeping them informed, maybe giving them some information about their route or their destination. But the way that we see that evolving is connectivity being the foundation for automotive experiences. And that really can be best viewed in two different use cases. The first relates to the software-defined car. Which is a very important trend at the moment, in which instead of defining what the vehicle means to the consumer, its DNA, if you like, through the hardware configuration, it's all about the software configuration. And of course, the way that you maintain or even update that software configuration while the vehicle is in the field is through connectivity. And this gives the OEM a new way of building a relationship with their own vehicles. Historically, it's all just been about the one-off product sale, and the CRM was all built around just getting the consumer back to buy their next vehicle from them. Now, with ubiquitous connectivity and software-defined vehicles, the automaker can maintain a relationship, as it were, with their vehicles throughout its whole life cycle, and even beyond the first consumer. So maybe the first owner of the vehicle is someone who really values performance, and they can specify the software configuration of the vehicle all around acceleration and handling and so forth. And perhaps a subsequent owner will prefer something that is more economical or oriented around comfort, or really values autonomous driving functions. And of course, through remote over-the-air software updates, the OEM can deliver that experience to the next consumer and derive revenue from that, whether that's through one-off updates or subscriptions to different kind of services packages. But of course, the only way you can do that is if you have that connectivity foundation. If we look even further ahead, the next kind of use case that we see for automotive connectivity is really around cooperative mobility. So vehicles sharing information with each other about themselves and their trajectory, or even what their embedded sensors can see, to create a more sustainable, coordinated, and of course a safer driving experience for everyone on the road. Now, what both of these kinds of experiences need, whether that's maintaining the SDV or cooperative mobility in V2X, is a very different automotive understanding of the cellular network, not only in terms of coverage, but also in terms of the performance of the network.
Wow, that sure does take it up a level from just having an infotainment system and listening to music in the car. So with that thought in mind and the idea of the role of software, what are the challenges that automotive software developers face and the OEMs in themselves when it comes to connectivity, and what's required from them to overcome this?
Yeah, that's a great question. Well, I mean, of course, in the automotive market, the problems that they face always begin with the OEM and their customer, and then flow down the supply chain to the software developers. Now, if we think of the biggest problem that automakers face today with their consumers when it comes to connectivity, frankly, it's around monetization of connectivity. The current strategy is to bundle up services in different telematics or infotainment packages, which are offered for a free trial for a certain period of time. And then they try to monetize that with the consumer through a monthly subscription. Now, we know from our research that the churn rates are extraordinarily high, like 90% plus sometimes. Consumers just aren't willing to reach into their pockets to pay for the kinds of services that are being provided. And what that really boils down to is the fact that OEMs are struggling to innovate and to come up with new services, new use cases that consumers think are valuable enough to pay for, especially if a lot of that can be replaced through simple smartphone mirroring. And so what automakers really need to think about, along with their enabling supply chain, is how can they more rapidly innovate on new connected car features to improve their monetization strategies. And there's a few different things to unpack there. Frankly, at the moment, there's a lot of repetition of efforts between different automakers when it comes to, shall we say, the plumbing of their connected services development. And so leveraging open source, leveraging open standards, insofar as possible, reusing the plumbing so they can focus what resources they have on areas and applications that are differentiating. That's going to be a really important step. That's something that the automotive industry is really grasping when it comes to embedded software development. But now they need to take that up a notch and apply that to their connected services development as well. And I think a related problem that automakers have as they try to push the boat out is maybe not always understanding what the network is capable of and where. It's a little bit of develop a use case and hope the network performance is going to be there to support it, which obviously doesn't result in great consumer experiences. Once again, makes it hard to monetize those connected car services. And so that is where the use of APIs and generally what Nokia is looking to achieve with network as code platform is very interesting, because it starts to empower automakers to better utilize the capabilities of the network in the same way that in the embedded architecture, middleware and operating systems help them to get the best out of embedded compute.
Yeah, so we've got to somehow marry up the automotive software developers who know what they're doing and the network folks and get them to simplify so they can work together. Cool. So an interesting thought that comes to mind is regionality and your sense for, you have a finger on the pulse of market evolutions. In your view, are there any main differences in connectivity requirements between North America and other global regions?
Yeah, so I would say overall, the trend is one of convergence. We're seeing regions becoming more and more similar in terms of the use cases and what consumers want, and therefore the network requirements to support those use cases, but there are some differences. I would say China obviously takes the lead in terms of the nice to haves that we talked about before, those kinds of superficial use cases. As the typical Chinese consumer has a different expectation and relationship with their vehicle compared to, say, the typical car owner in Western Europe or North America, really pushing the boat out in terms of things like in-car gaming or, rich multimedia experiences in the cabin, when the vehicle is stationary. And so there's obviously a real lead in terms of that demand for, network performance-driven, highly data-consumptive use cases in the Chinese market. But we can expect to see those spread, more globally as other regions converge to where China has led in terms of electrification and automation, and also as a new and younger generation of car owners comes through. In Europe is probably where we have seen the lead in cooperative mobility. Now, it's still very much in a green shoots kind of phase, but it is where we've seen the coming together of everyone who you need in that ecosystem of automakers, tier ones, telematics service providers, location intelligence service providers, network operators and infrastructure suppliers to start sharing information across brands, across different vehicle types, and across the different countries of Europe. so that you can cooperatively identify where different hazards are and start to adjust driving policy today by informing drivers, maybe in the future by informing autonomous driving systems that there's a lane closed up ahead, or there's a stationary vehicle in a certain part of the highway just around the corner. I'd say when we think about North America, one difference that we've seen between North America and Western Europe, in Western Europe, maybe there is more of a willingness to roll out a service that requires a certain network performance that isn't available everywhere, maybe only available in certain cities, maybe only available in certain cities, especially if they're closely related with premium OEMs that are very strongly associated with those cities. And generally a European OEM, especially a premium one, will say, yeah, let's go ahead, roll out this service, even if it's only available in these certain locations, and we'll expand it over time as and when that's possible. Whereas in North America, we tend to encounter more of an attitude of, well, when it's available everywhere for all of my consumers in every relevant part of my market, then we'll roll out that service. So just a few subtle differences against a backdrop of an overall global trend, which is one of convergence.
Amazing. James, thanks. I appreciate it. We wanted to do this concisely in 3 questions, but you've given us a complete education and your insights into the automotive industry and how it affects the network API economy. So thanks, really appreciate it.
My pleasure.